So we are looking now at topic 10, expressions and operators in C, talking about what an expression is. We will look at various operators, the arithmetic operators, assignment, increment and decrement operators, relational and logical. We'll look at the bitwise operators, talk about precedence and associativity, and then we'll wrap it up with the ternary and comma operators. So expressions in C are built from variables, constants, operators, and function calls. So basically an equation that can be made up of any combination of variables and constants, function calls, and then of course operators. So examples here, line 1 is an expression. It does nothing, but it is an expression. It evaluates to the value of x. We have an assignment expression, y equals 0, 3 plus 4. We have a relational operator, age is greater than 18, sum equal to 5. And then line 6, we've got a little bit more of a complex expression where we are calling a function and then we are subtracting 1. So you can mix and match function calls and operators and whatnot. So the arithmetic operators, we're all familiar with them. They enable us to do computations. We've got addition, subtraction, and so on. The only things that you might not be familiar with here would be modulus. So we are dividing x by y, and then we are taking the remainder. And then, of course, we talked about the division operator, where it is integer division if both of the operands are integers. So if you divide like 5 divided by 2, it's going to truncate or throw away the fractional part. If at least one of them is a floating point, then it'll be floating point division. Okay, assignment operator, straightforward. It assigns values to variables. We say that it has the side effect of taking the value on the right and assigning it to its left. In other words, it changes program state. When you take CS 3342 next year, programming languages, and you talk about functional programming languages, you'll learn about side effects and how in some languages we try and minimize side effects as much as possible. So some examples of the assignment operator here. Here we're doing multiple assignments. So I'm assigning x to 3, and then that evaluates to 3, that whole expression evaluates to 3, adding 1 to it, and that then assigns 4 to y. We can have multiple assignments on the same line. We say that the assignment operator is right associative. So what that means is we start from the right, we assign 10 to w, we then assign w to z, and so they both then are assigned the value 10. Just one thing to note here, this does not assign 5 to both a and b. It only assigns 5 to b. In this case, a is left uninitialized. Now, depending on your compiler may initialize that to 0 for you. When I tested it last night with GCC, it didn't. It just gave me some random junk that was already in RAM. Okay, so you have to be careful with that. It's best to always initialize your variables. Now, in addition to the simple assignment operator, we have the compound assignment operators. You've got this in Java as well. So it's often the case that we need to use the old value of a variable to compute its new value. So x equals x plus 1, y equals y times 2, and so on. And so C offers us the shorthand, just like Java does, where we can say some variable, operator equals, and then an expression. And that is equivalent to variable equals variable operator expression. Okay, so we have things like x times equals y. That's the same as x equals x times y. X plus equals y divided by 8. X equals x plus y divided by 8. In addition to the simple arithmetic operators, we've got things like the bitwise operators, which we'll talk about in a little bit, where I'm saying, all right, take a and it together, the bitwise and, with the hexadecimal integer 0xf0. So a equals a anded with that integer. And same with things like this, we've got one of the logical operators. So C and equals x greater than 5. We're saying C equals C and x greater than 5. So just one thing to note here, that compound assignments have a value that's equal to the final value of the expression. So here we evaluate x plus equals 3. So x equals 3. We evaluate x plus equals 3. That sets it to 6. That expression then evaluates to 6. and therefore 6 also gets assigned to y. Okay, we've got these again in Java, pre-increment and post-increment and decrement operators. So pre-increment operator is going to increment the variable, and it will evaluate the entire expression to whatever the previous value is plus 1. So if I've got x equals 1, I say plus plus x, that increments it to 2. I then say plus plus x again, that increments it to 3, and that evaluates to the new value, to the old value plus 1. So y also gets assigned the value 3, so as we would expect. We then decrement minus minus x, that decrements it down to 2. Do it again, decrements it down to 1, and because we're using the pre-decrement operator, it evaluates to x old minus 1, and therefore that value 1 is also assigned to y. Now, the post-increment and decrement operators have the same side effect of incrementing and decrementing a variable, but they evaluate to the old value of the variable. So again, if we have x equals 1, I increment it with post-increment, same thing, increments it to 2. But in this case, when I increment it in this expression, it does increment it, but this evaluates to the old value of x, and so y gets assigned the previous value 2, whereas x is incremented to 3. Same idea here, we decrement it to 2, decrement it again, but again, this expression evaluates to the old value of x, and so y gets assigned its previous value 2. Okay, we've got the standard relational operators, equal, not equal, greater, less than. The difference here is that unlike in Java, where these operators return true or false, you have to remember that in C, the bool type was only added in C99, whereas C has existed since, the 70s. And so they already had all of these relational operators, so they can't change the language and make them return true and false because that would break all of the existing code. So instead, when they started out, they had them return 1 to mean true and 0 to mean false. Okay, so just to be aware of that. And again, C treats any non-zero value as true. So if it's minus 1, if it's 1, if it's 5,000, they're treated as true. If it's 0, it's treated as false. And just a common source of bugs, it's x equals y. When you're testing equality, it's not x equals y. That is, of course, the assignment operator. The compiler will generally not catch that, and so that will lead to a bug. Okay, we've got the logical operators. Logical operators are used to evaluate Boolean conditions and determine the flow of control in our programs. We've got logical and, or, and not. Again, I think we're all familiar with these from Java. And of course, we can combine multiple operators together to form more complicated conditions. I would recommend using parentheses to clarify the precedence in your conditions, especially if you have long, complex conditions. I think it enhances readability to put parentheses around each one, but I'll leave that up to you. Now, one thing to note here is that and or, the logical and or operators use short circuit evaluation. So with the and, it will evaluate the first operand. And if that evaluates to false, to 0, then it's not going to evaluate the second operand at all, because false anded with anything is going to be false. So we don't need to evaluate the second operand. Same idea with or. If the first operand evaluates to non-zero, in other words, to true, then we don't evaluate the second operand because true ORed with anything is going to be true. So to see an example of that, the printf function does return a value. It returns the number of characters it printed to the screen. Okay, so this is going to, I'm going to call printf, it's going to print hi. It's then going to return 3, which is a non-zero value, so it's true. So we have true anded with 0, which is false. And we know that false anded with anything is going to be false. So short circuit evaluation kicks in and it says, okay, well, I don't need to then evaluate this statement because we already know the expression is false. And so it only prints out hi here instead of hi and bye. And then same idea here. So once again, printf returns the number of characters that it prints to the screen. So it's going to return 4. 4 is non-zero, which is true. True ORed with anything is going to be true. So it does not need to Evaluate this expression, short circuit evaluation kicks in, and it only prints out 1. Okay, just something to keep in mind. All right, bitwise operators. So they allow us to operate directly on the binary representations of our integers. They only work on integers, they don't work on floating point numbers. And they allow us essentially to manipulate individual bits. So all integers, as we probably already know, are represented in the computer as binary numbers. So however we decide to represent them, we're usually representing them in base 10 in decimal, but you could represent them in hexadecimal if you use 0x. You could represent them in octal if you have a leading 0. So however you choose to represent them, that's up to you. Internally, they're represented as base 2, as binary. Now, one thing to note, if you are looking online, you may see that, oh, you can represent binary numbers in C using a prefix 0b. So I could say something like 0b 11110000. That is an extension from GCC. So they have added that to their compiler. It is not part of the C standard, which means that if you take that code and you try to compile it on someone else's compiler, it may not compile. So it's no longer portable. So I don't recommend using that. So the bitwise shift operators, let's suppose for the sake of argument, so that we don't have to work with 32 bits here, that our system uses 16-bit integers. And we've got this variable x, it has this value stored in it. If we use the left shift operator, it will shift the bits in that variable n positions to the left, and it will shift in zeros on the right. So if I've got, x shifted to the left by 2, it's going to take x, it's going to shift in 2 zeros on the right, and it will move all of the bits 2 positions to the left. And then the leftmost 2 bits will be discarded. Same idea here with the right shift. We're going to shift the bits in x n positions to the right. The difference being here that if it is signed, so in other words, if it is a 1, if it's a negative number, then it's going to shift in the sign on the left side. So if it's a positive number in a signed variable, it'll shift in zeros. If it's a negative number, it'll shift in ones. If it's an unsigned number, so we have like an unsigned int, for example, it's going to shift in zeros. Okay, but same idea here. So, we've taken the value of x in a signed variable, it would shift into ones because the sign bit here is 1. In an unsigned variable, it shifts in 2 zeros, and everything else gets pushed to the right, and then the rightmost 2 bits get discarded. Okay, we then have the bitwise logical operators. So just quickly going through these truth tables, hopefully we're familiar with AND. AND is going to be true, the bitwise AND is going to be true only when both of its operands are also true. Okay, so if we do X and Y in our code, it's going to look at each individual bit. 1 and 0 is 0, 1 and 0 is 0, 1 and 1 is 1. And then the rest are all zeros. And so that gives us our bitwise AND result. Bitwise OR is going to be true, 1, if at least one of its operands are true. Okay, so 1 or 0 is 1, 1 or 0 is 1, 1 or 1 is 1, and so on. XOR. XOR is exclusive OR. So it is true if one or the other operand is true, but not both. So 1 XOR 0 is 1, 1 XOR 0, 1, 1 XOR 1 is 0, and so on. And then finally we have the bitwise NOT, or the bitwise complement, and that is complement with an E, not complement like you're looking nice today. So that simply flips the bits. 0 becomes 1, 1 becomes 0. We call this the ones complement. So if I want to take the ones complement, if I want to flip all of the bits, I do tilde x, and that will just simply flip all the bits in that integer. Okay, so they're not operators you use every day, but sometimes they can come in handy. Now, at a CPU level, so if we want to be really, really efficient, let's say we're writing some code for some sort of embedded system that is sort of resource constrained. At a CPU level, as you will likely learn in CS2208, Multiplication and division require quite a few clock cycles, whereas the shift operation is generally done in one clock cycle, which means that if we need to multiply by 2 or divide by 2, we can replace multiplication and division by a shift. So multiplying by 2 can be replaced with a left shift by 1 bit. So you can see here, I'm doing 10 times 2. Alternatively, I could do a left shift by 1 bit to accomplish the same thing, to multiply it by 2. So to see why that is, this is the binary representation of 10, 1, 0, 1, 0. If I shift that one position to the left, then this number gets shifted over one position, so now we have 16 plus 4 is 20 instead of 8 plus 2 is 10, right? So it doubled it. Same thing here. We're multiplying by 4, 10 times 4. I can then shift 10 to the left by 2 bits. So again, if we look at that, we shift in 2 bits. That whole number gets pushed over to the left 2 places, and now it's 32 plus 8 is 40. So we've just doubled it. Okay, so if you're multiplying by 2, you can do it more efficiently with a left shift. Same with division. So if we're dividing by 2, at least for positive integers, it doesn't always work for negative integers, you can replace it with a right shift by 1 bit. So if I'm dividing 10 divided by 2, I could equivalently say shift 10 to the right by 1. Okay, so again, we've got 8 plus 2 is 10. If I shift it to the right by 1, that shifts those 4 bits over. We discard that rightmost 0. And now I've got 4 plus 1 is 5. So I've divided it by 2. Same thing here. Divide 10 by 4. I could do a right shift by 2 bits. And again, we are just simply shifting those over 2 bits, and now we have a result of 2. So it's integer division, right? It's discarded. It would normally be 2.5, but we're doing integer division. Okay, operator precedence. I do not expect you to memorize this table, obviously. This just sort of shows which operators have higher precedence than others. So in other words, which operators are evaluated first when we have expressions. So operators with higher precedence will be evaluated before those with lower precedence. So the ones at the top of the table have the highest precedence, and then we go down from there. So we have things like, the postfix increment. So the post increment operator has higher precedence than, say, multiplication. So if you had like 5 times x plus plus, it's going to evaluate that x plus plus first, and then it will evaluate the 5 times whatever that is. Okay, so understanding the precedence rules, or at least having a basic understanding, helps you to understand how it's going to evaluate complex equations or expressions that you have in your code. You can, of course, override precedence by using parentheses. So anything you put in parentheses, that will have the highest precedence in your expressions. Now, the notion of operator associativity, I talked about it briefly earlier. So precedence tells us the order in which, it tells us which operators get done first. Whereas associativity says, okay, we've got these operators at the same level of precedence. What's the order we're going to evaluate those in? So to give an example here, multiplication has higher precedence than addition. So we're first going to evaluate y times z, of course, and then add that to x. Okay, so standard rules, Bedmiss, right? Multiplication and division followed by addition and subtraction. Now in this case, we're using multiple assignment operators, so that has the same level of precedence. And so we have to look at the associativity. And we see here, okay, the assignment operator is right associative, so we go right to left for that. And so we first take z, we assign it to y, take that value, assign it to x, take that value, assign it to value. All right, the ternary operator gives us a way to sort of embed an if-else statement into one of our expressions. So the generic form is we've got some sort of expression, we've got our ternary operator, we then have our then clause, so our then expression, expression 2 there, and then we have a colon followed by our else clause, our expression 3. So that is essentially equivalent to saying, all right, if expression 1, then return or evaluate to expression 2, otherwise evaluate to expression 3. Okay, so it's useful for cases like this where you've got some like short, concise, conditional code. So on line 1, I am getting the maximum of 2 variables, x and y. And so we're saying, okay, if x is greater than y, then we evaluate that to x, and that gets assigned to max. If x is not greater than y, then y will be assigned to max. Okay, it's a little bit more concise, and I would argue more readable than having this big if-else statement just for that very, very simple conditional. Same thing here. So maybe you've got a function and you want to return a string based on someone's age. So if age is less than 18, we're going to return child. Otherwise, we're going to return adult. Okay, so when you use it judiciously, it can enhance the readability of your code. Rather than having this big verbose if-else block, if you've just got a very simple condition, then use the ternary operator. If you've got very complex conditions, you've got this big, long, condition, avoid using it. If you've got nested ternary operators, avoid using it. Just fall back to a standard if-else. But if it's a very simple one, then yeah, feel free to use it. And then finally, we have the comma operator. So comma operator is really we only use it in practice in the for loop really, but you could do something like what you see on line 3 there. So comma operator allows us to have multiple sub-expressions in one expression. And what it will do is it will evaluate to the value of the rightmost expression. So on line 3, we've got a++, comma, b++. So 2 sub-expressions. And that entire expression will evaluate to the value of the rightmost expression. So a gets incremented to 4, b gets incremented to 5, but of course it's the post-increment operator, and so it evaluates to its old value, which was 4, so c will be assigned the value of 4. Okay, don't do something like that, and there's no reason to do that, just put them on different lines. It just sort of illustrates how the comma operator works. Of course, we use it most commonly in for loops, so on line 7 there, we are using it both for the initializer to initialize 2 variables, I and j, and then we use it in the loop expression as well to both increment I and decrement j. Okay, and that's it for this topic. It was just a short, sweet topic. Maybe not sweet, it was pretty boring, but nevertheless, it's important to know our operators. So we saw tons of different operators. I don't think I need to repeat all of them, but you can use this as a reference when you are coding. Any questions?